Dzień dobry. Welcome to my presentation. I'm Mark Paluch. I'm working with Pivotal, and I'm Spring Data project lead there. And today I'm going to talk about reactive relational database connectivity. So to make that talk sense to you, we first need to talk about the problem we're trying to solve or what brings us there. So we're talking about reactive programming, and probably you've seen already a couple of reactive talks. So it's all going in a similar direction. So we also, from a Pivotal perspective, see that reactive programming is the next big frontier that will accompany us across the next couple of years. Why reactive? Well, there are a couple of reasons, but in this particular scenario, we are talking about reactive programming because we need to solve the problem of blocking. And to get there, that blocking behavior of the imperative style programming becomes a problem. They need a lot of requests, a lot of throughput to even get to that problem. So this is probably not a problem that everybody has, but once you get there, then you suddenly realize that if you are blocking CPU threads, you quickly run out of computing power, you quickly run out of memory, because these are limited resources. And the only thing that can help us is a switch in the programming model to a non-blocking variant. Generally speaking, reactive programming has no notion about concurrency or asynchronicity. Most things still run on the same thread because this is the most efficient way how to process workloads. But in some scenarios, when we go into I/O work, then we incorporate some notion of asynchronous processing because we no longer keep that thread blocked until we get a response, but rather we process other things, other useful work that we can do there. And one of the key differentiators between reactive programming and asynchronous programming is that in reactive programming you have this notion of flow control built in. You rarely have things like loops, but what we rather have is that you process element by element, and with this pull-push back pressure, you give some notion to the underlying framework how much capacity you are able to process at a time to not overwhelm a slow subscriber with a fast producer. Now, probably you have seen also already throughout the conference a bit of reactive code. And if we want to be reactive, we have to be reactive everywhere. So from the beginning to the end. What we typically do is we incorporate a lot of I/O-bound work when we think about reactive programming, that we reach out to things like multiple services. Like in this example, we reach out to the alpha service, to the Bravo service, to obtain the health check from both services, and then return a composite health check object. Now, another aspect that comes with reactive programming is this declarative nature of programming. So we no longer recognize this piece of code as imperative style code, where we declare things to happen in an order, but rather we declare things in a recipe way that we express, okay, here, dear web client, issue a GET request to the alpha service, issue a request to the Bravo service. And at the time where we declare this functional reactive sequence, nothing really happens until we give this publisher to somebody who is then able to execute that, or how we call it, materialize. And then some infrastructure component is really doing then the actual work. So initiating the connections, reaching out to the first service, reaching out directly to the second service without awaiting the first result. And as soon as both responses come in this example, we then continue with the mapping stage. And during all this I/O work, the thread that is executing all these requests can do more meaningful things. And this is also one of the drawbacks that we see, that switching from imperative to reactive entirely changes our understanding of the code. So everything that we have learned in imperative, well, I think 75% of that we can throw away. The patterns typically stay the same, how we approach things. But the way how we express our intent in the code entirely changes. So this is one of the key aspects. Another of the key aspects of reactive programming is as soon as you encourage into threads, stack traces become sort of meaningless. Debugging gets harder. But well, if this is the price that we are accepting to pay for that, then we need to come back to this fundamental assumption that if we want to be reactive, we have to be reactive everywhere. As soon as we start dropping in blocking components into our system, we get, guess what? Back to blocking. And this is something we really need to eliminate. So in order to be reactive everywhere, all our integrations have to be reactive. We have seen the Spring WebFlex web client, which is a reactive web client for HTTP requests. So talking HTTP to other services, check. If we want to integrate with messaging systems, like with RabbitMQ or with Kafka, yeah, there are reactive integrations for that, check. But you know what? A fair amount of what we do with our application incorporates more than just event-driven, event-based processing, just beyond the idea of sending events around. A lot of our business processes, of our business logic, relies on a state, on persistent state. And this is typically something when we hear about microservice persistence and state, then we turn down and pretend there is no such thing. But in reality, we have to deal with state. For several databases, there are reactive integrations like with MongoDB, Apache Cassandra, and Redis. This is nice because this small fraction of folks using these NoSQL technologies can utilize that in their applications. However, a much bigger fraction of the Java ecosystem still is using SQL databases, relational databases. And the only technology today to access these databases is JDBC, and JDBC is a blocking technology. And this brought us rather quickly to the question after releasing Spring 5 with the reactive runtime, what about Postgres? What about MySQL? And our answer was, yeah, sorry, there is no such solution. However, after a couple of months, we were actually sick of that question and started investigating which alternatives we have. And this is what really brings me to this talks, because none of the alternatives that we tried were sufficient enough to satisfy the needs and the demands of the reactive programming model and to eliminate the idea of blocking. And after the Spring 1 conference 2 years ago, we as a team got together, and typically, as you probably know, after a conference you are pretty exhausted, you have perhaps had a party last night and you're still drunk, and one of our colleagues thought, what if we would start writing an own driver? And then, back then, everybody thought, yeah, go home drunk. But eventually, this became reality. And this reality is called RTDBC, Reactive Relational Database Connectivity, which is a specification designed from ground up for reactive programming and to embrace reactive programming patterns. So although the idea sounded crazy, because really nobody is keen to write a database driver just for fun, somebody started with this piece of code, started with a proof of concept. And the idea which drove us was, let's make this as easy as possible to adopt. See, today we have, yes, Java 12, Java 13, Java 14 is in preparation. So you could say nobody uses Java 8, but the truth is, like 90% of the folks are still developing against Java 8 APIs because this is the de facto standard what we use. Maybe we use in production a newer JDK, but still we want to lower the barriers to entry as low as possible. So the core idea was, okay, let's start out with Java 8 as a core dependency for RTDBC. And since we are talking about reactive programming, and there is in Java 8 no reactive programming API baked in yet, we have to rely on reactive streams. And as you probably know, with Java 9, reactive streams went into the JDK. So looking on RTDBC from a Java 9 Plus perspective makes RTDBC dependency-free. No Netty, no Spring, nothing on RTDBC SPI level. So this means you drop it into your project, and you don't really pollute your project with dependencies. Another idea that we came up as design principles was to really be reactive everywhere, to embrace reactive types and patterns. And we will see this throughout the course of this presentation, that we are reactive even down to the database, leveraging database-specific features to transport things like back pressure. We also didn't want to just drop a bunch of classes and be done with that, but rather the intent was to come up with a fully documented specification that tells you what you can expect from RTDBC and what you as a driver developer have to deliver and what you as a client author can expect from RTDBC to give you. Now, JDBC is a great technology. It is very mature. It proved very, very reliable, and it came up across the time with very, very cool features and ideas. However, JDBC serves two things, two purposes. One is to abstract drivers away, and the other is we as application developers should be encouraged to work with JDBC directly. Well, thing is, JDBC isn't pleasant for driver developers because they have to implement a lot of specific user space features which aren't database specific. And on the other hand, I think most of us use something else than JDBC directly. Perhaps we use MyBartis, JDBC template, Hibernate, these kind of things. But nobody really loves using JDBC except if you are really heading for the very last bit in performance. So we thought, let's learn from this journey of JDBC and make the RTDBC SPI a pure SPI, which is a service provider interface with minimal surface that abstracts only these parts away, which are database specific. And this enables then client authors to build on top of RTDBC to provide a more humane API. So what do I mean with humane API? These are the things that take things like JDBC and build more functionality, more abstractions on top of that, like Juke is providing with their DSL to generate SQL, like JPA is doing with mapping of entities, these kind of things. Now, one thing that we also notice is there is a lot of convenience in JDBC with this parameter bind markers with this question mark. But what really happens there is that every driver developer has to implement SQL parsing, and believe me, this is not the most fun thing to do. And they have to look out for these question marks and replace them with database-specific, so vendor-specific, if you want to so, driver-specific bind markers. So they are rewriting the SQL. And this is something that RTDBC isn't doing, and we will see a few examples afterwards. Now, let's walk you through the RTDBC SPI. We have like 5 interesting interfaces. All the other stuff is exceptions, enums, not really things that we would get in touch with that. And it all begins with a connection factory. So if you know what a data source in JDBC is, then this is the pendant to RTDBC, a connection factory. Connection factory can create a connection. Well, perhaps obvious from that time. So this would be the entry point for you into your driver. And as soon as you subscribe to the creation publisher, you get a connection method. This is the core idea. But you know, there are several use cases where it is handy to hide other functionality behind such an interface. Things like connection pooling. We do not necessarily want to expose another interface just for the sake to express this is connection pooling. What we really want to do is obtain a connection and close it afterwards. Or if we go into routing towards multiple databases, we do not necessarily need to carry this fact outside, but rather let's implement a connection factory that performs that routing. So a connection factory can be either a driver or a component that builds on top of a driver and provides you with proxying features, with routing features, these kind of things. Good. Once we have that connection in our hand, then we start operating on a connection itself. And a connection has a lot of methods which deal with transactions. See, SQL databases are all about transactions. It's all ACID, right? We deal with save points. We deal with auto-commit mode. We'll deal with isolation levels. We have to deal with that because this is part of how SQL databases work. But this isn't necessarily something we want to deal within our own application. However, client developers that provide this functionality with transaction control, transaction management, need this functionality to take some sort of input guidance from our application code and translate that how our piece of work, how our unit of work is going to be used. Now, perhaps the only two methods on the connection interface are create batch and create statement. Create batch is a collection of statements, so let's directly go into the statement interface itself. Statement can be either parameterized or not parameterized, so you create a statement by handing in some SQL, and we feel it is not important to express also whether this is a stored procedure, whether this is a simple unparameterized statement, whether it is parameterized. We just say, okay, this is a statement. If it's not parameterized, you execute it right away. If it is parameterized, you start binding values to that, either actual values, scalar values, or null values. Good news here is the indices start counting at 0, so no longer +1 counting. And once you are happy with your binding, then you can optionally express that you are interested in returning generated keys, so things like auto-increment columns can be returned to you. And then you finally execute that statement, and it emits one-to-many results with the publisher. So see, all places that are incorporating a database conversation communicate through a publisher. We do that, and we have to do that to allow us to encapsulate all that I/O and to not block your application. And then the result can be consumed in two ways. The first one is to get the number of affected rows. So if you insert, update, delete rows, this is probably something you would like to consume. Or if you are consuming tabular data, say a select statement, then you would be interested in consuming row data. In a humane client, you would be interested just in mapping the rows, because if you hand in some known SQL, you know which columns come back, so you deal just with the row. And row metadata contains additional information about which rows are available, type information, these kind of things. So again, something which is intended for client authors mostly. And then when we take a look on the row interface, it has a get method that takes an identifier. This can be the column index, so 0, 1, something, or the name, and additionally a class type hint, so that if you deal with a say date with time component, and you're interested only in the local date component or in the local time component, then you hand in local time and you get the appropriate value back. And again, here we use the modern date-time API. We use modern types to allow us to come up with a modern SPI and not limit and restrict ourselves to a certain pattern. So how would this look like if we would use RTDBC in our code? Well, expect a lot of code. And this is the first slide with a little code, so expect more. So it all starts with a connection factory. You create a connection, you get back a publisher of that emits a connection. As soon as we have that connection in our hand, this is the flat map many operator, which comes from Project Reactor. So in this case, we're using Project Reactor as composition library to make it at least somewhat usable. As soon as we get that connection emitted, we issue a select statement, select value from test. We execute that. And again, we are flat mapping the result, which means as soon as results stream in, then we are able to work with that result. And the result interface itself has a mapping method that accepts a function handed in with a row and a metadata. And since this is static SQL and we know that we are selecting value, we are putting also the getValue method in here. And what we get in return is a publisher of object. Because again, this API is generic, and currently it does not know anything about types. And so everything here is like a get object call in JDBC and returning your objects. To make this at least a little bit more usable, we can pass in a type hint and say, okay, when I call get to my value column, then I'm expecting this to be a string, and the driver takes care to return me a string representation of the value, and effectively this turns my result into a publisher of a string. And the publisher of string will emit as many strings as rows I'm getting, so I'm directly passing this stream of results back to whoever is going then to consume that publisher of results. Cool. This is the select part. How does this look for modifying statement? Well, similar. So again, it all starts with a connection factory. We create a connection. As soon as the connection is ready, we create a statement. And in this case, we're using an insert statement, which is insert into test values 1 and $1 and $2. So the first thing we see here is we are using parameters. And for those who are familiar with Postgres, yes, this is Postgres syntax. If we would use MySQL here, bind macros would be different. If we would use SQL Server, then bind macros would be again different. So we pass on these specifics to whoever is calling this code. And whether then in the application it matters that your application SQL code has to be portable or not portable, then this is a decision which client you are using, and no longer a decision and an aspect of the actual driver that is transcribing your SQL. Now, specifying bind parameters requires us also to provide the statement with the actual values. So we are calling the bind methods, bind $1 with 100, bind $2 with 200. And then we are not ready yet. But rather what we want to do now is run this statement multiple times. In the first case with parameters 100 and 200. In the second case with parameters 300 and 400. So we have also a sense of micro-batching added into this SPI. Drivers that support things like prepared statements could use this information and prepare a statement and run it multiple times. So compile it first, run it with a first parameter set, run it with a second parameter set. Databases that support execution in a single round trip, where they say, okay, I have here the SQL and a table of parameters, can execute this statement twice in a single round trip. And again, we are just specifying at this stage what we want to express, and then the driver knows best how to execute this certain functionality. Now, once we are done with our bindings, we execute that statement. The driver knows best how to execute that, and then the driver would emit to us 1 to multiple results, depending on how many query it is actually running. Now, since SQL databases are all about transactions, let's drop transactions into that picture. And when we talk about transactions, we have to begin a transaction. So at least disable auto-commit mode. Then run our own code within that transaction. This can be a single statement, multiple statements. And then once we are done with running our own code, we have to either commit that transaction or roll it back. And in this example, we are doing a rollback if an exception happens. But doing just a rollback isn't sufficient enough. We have to roll back and propagate that error to that caller to not drop that error. And as you might see, this is probably cool because we have now a non-blocking variant how to run things on SQL databases. But it is not the type of code that we would like to see in our own application. Again, the pattern that we also might be familiar from JDBC with begin, try, catch, finally try, catch to commit or roll back a transaction is the correct one. But this is way too much code, way too verbose that we could even think about incorporating that into our application code. And this is exactly the point where we are getting to the idea of enabling humane clients. So driven out of these examples, we thought, this is cool, but we need something that can be used from within our application. And inspired by JDBI, which is a JDBC client framework, we came up with the idea of RTDBC client. This is by no means a reference implementation or something similar. It is just something to show how we could imagine how to express functional reactive database access within our application. So let's walk through that code. And you will see this is much more readable, much more comprehensive. We create that RTDBC object with handing in a connection factory. And then we have this RTDBC object that we can then use to run our queries. And what we see first is we have this withHandle method. This withHandle method accepts a function. The function gets in as a parameter handle, so this is something which is associated with a connection. And on this handle, we can then issue multiple operations, like this select, and map the results that come back. And typically, when we do static SQL operations, that we know when we know how the SQL is formatted, which values, which columns are going to come back, there's no need to deal with row metadata at all. So the only thing that we do is we consume that row, say this is a string that should come back, and we get in return a flux of values. Why flux and not a publisher? See, RTDBC SPI is based solely on reactive streams. In reactive streams, we have only publisher, subscriber, processor, and subscription. RTDBC Client is an implementation, and there it is quite handy to use some sort of reactive composition library. And since Project Reactor is built at Pivotal, we also decided to go with that idea for the RTDBC Client itself. But you know, this could be every other kind of library. It could be Akka streams, it could be RxJava. Now, this flux of values emits us a stream of values that are produced by that SQL query. And this is much more usable from our perspective because we do not need to allocate a connection. We do not need to close that connection. Closing the connection was, by the way, missing on the previous slides. Otherwise, it would have made the slides even bigger with that code. And this is something we get just out of by using that RTDBC client. Now, if we go into modifying statements, we have also thought about that. Let's provide a create update method that accepts update statements, insert, update, delete. These things typically use parameters, bound parameters, because we want to insert data or modify it. We do not want to encode these parameters as strings, because as you know, this is one of the most security sources for bugs. Therefore, let's provide bind methods on that end and pass that through to the statement. Once we are happy for executing, we execute that update statement, and typically we are interested in either completion, is this thing done, were these statements executed, or if we want to get fancy, we are interested in how many rows were really affected by that particular statement. Now we can have that also with transactions, and probably, let's go back one slide. So you didn't probably notice too much. Pay attention to this withHandle method up there. So withHandle gives us resource management. If I want to use transactions, I call simply a different method, which is inTransaction. And now I get resource management, and I get transaction management for this 90% case. I want to begin a transaction and roll that transaction back only if an error happens. Otherwise, I want to commit that. And everything else of my code stays basically the same. And this is where the true value of a client library really lies. It gives us, as the application developers, the productivity, the features that we need to solve our particular business case, and which client library is appropriate really depends on our ecosystem, on our team, and the business things that we want to address with that. There is no single client that spans across all these things, and that gives you everything without drawbacks. You always have this pro and con side, and this is how RTDBC client oriented on JDBC could look like. Now, you probably remember I'm working on a Spring Data team, and we also took a look on how this could look like from a Spring Data perspective. We have this JDBC template for JDBC things in Spring Framework, and we considered how can we translate that into a reactive world. Just coming up with a RTDBC template didn't feel right. So we took inspiration from Spring Webflux web client and came up with the idea of a database client. And the database client allows you to express in a functional way what you want to do, which data you want to access, and gives you all these nice aspects that you might be already familiar from a Spring Framework itself. You create that database client with a connection factory, and based on this information, you get some dialect-specific support. See, in this example, I picked the execute method, where you hand in SQL and you want to bind parameters. And since productivity and portability is key in Spring Framework, let's reuse what we already might be familiar with from the named JDBC parameter template, where we take named parameters and the framework itself does the translation into the vendor-specific parts. And since names are much more expressive than anonymous question marks, this makes a lot of sense at this area. So this select asterisk from person where name equals the double column name is then handled and translated by the Spring Framework itself and not by each and every driver implementer itself. We can bind values. That's obviously a thing. We can bind scalar values to that. If this would be an in-query, then I would be probably wanting to bind a collection to that, to say, okay, we're name in first, second, and third, and to not generate all these additional bind markers, because in SQL you have to express every single element with a bind marker. Spring Data is also taking care of that for you, that you do not need to care about how much of these in elements would be in your collection. You can express how you want to consume the data. By default, you get a flux of map of string to object. This can be useful at times, but this is typically not the way how you think about data. You think about your domain in persons, in orders, in context, these kind of things. So why not just leverage the meta model information that we already have for other Spring Data projects and say, okay, I want to consume this result as person. And Spring Data allows you to do so. It says you can specify a domain type, and this turns the publisher of results into a publisher of person, so a flux of person. Afterwards, you say how much of the data you want to fetch. Do you want to have all the rows, just the first one, all of the, or just exactly one? And Spring Data is going to give you also these guarantees. And if the query yields more than one result and you're interested in exactly one, then the publisher will terminate with the error and say what's happening there. So you get also these guarantees that you're familiar with from JDBC template. But really, database client is a little bit boring because this is just the foundation on which RTDBC repositories are built on. Because this is the real thing that we want to work with as developers. We do not want to work with low-level clients, low-level APIs, but rather we want to deal with repositories that allow us to use predefined query methods, like with insert, save, save, delete, find by ID, these kind of things, and that also allow us to specify our own queries. Right now, we support annotated string queries with the very same syntax that we have seen with the execute method, that we can specify parameter bindings that are bound by name and run these queries. Query derivation is something that will come in a future revision. And I think this is how we should envision and think about functional reactive database access when doing reactive programming. Now, there's a little bit more to that, because currently we have seen RTDBC client with transactions, but what about Spring Data and Spring transactions? And short excursus to that. Well, in Spring and in every other framework, transactions are thread-bound, because these are invisible aspects to your code. The only thing that you have there is either transactional demarcation or a transaction template, or something different that tells the framework when to start a transaction and when to end it. And all these information are typically bound to a thread local variable. Since Reactive has no notion about threads anymore, threads happen, but we do not have so much control over that. We need something different, and so we have built Spring's Reactive Transaction Management with Project Reactor's context feature, where you can attach runtime information to a particular execution, to a particular flow, and then benefit from these information as a framework so aspects can decorate your code. And what reactive transactions really look like in Spring Framework with reactive operators is, well, they are exactly the same style how they would be expressed in imperative style coding. You can use at transactional on method levels. The only thing which is different is the return type. We no longer deal with a void or a person, but rather with a mono of void or with a flux of person. And everything else is managed by Spring Framework itself. We have also a programmatic alternative, which is the transactional operator. And when you are already familiar with chaining functional reactive calls, the transactional operator is in line with that idea, where you spin up a transactional operator instance, give it a transactional manager object, and as a final step before you run your sequence of reactive operators, you say, okay, as reactive operator in transaction, and then you have, again, a fluent style how to express transaction boundaries. And everything which happens before the transactional operator is within the transaction, and everything that happens afterwards, if I would chain additional calls, would be outside of that thing. Now, there's a cool feature in JDBC for configuration frameworks. Not so much for us users, because in JDBC, the connection URL is not so much specified. Every driver vendor can come up with their own scheme, and they have also to implement their own parser. MySQL looks different than HSQL, than SQL Server, and this is sort of a pain. But the good thing is they have discoverability, and they have this idea that you come up with a string, drop it into your Spring Boot application, into your JBoss, into whatever uses JDBC, and then you get your driver configured. And this is a pretty cool idea that we wanted to retain and make it even better. And make it better by standardizing that format and taking off that burden so that not every driver developer has to implement URL parsing on their own. Because if they would implement URL parsing on their own, they would again start doing fancy things, and this is something we want to prevent. We want to standardize that format. We want to do that parsing in RTDBC itself, and then give that configuration object to somebody, actually the driver, that is able then to give you a connection factory out of that. And we also have features like delegation that you can configure with a single URL, not only your driver, but also things like a connection pool. Here in this example, this URL would be taken to the connection pool component, and the connection pool knows, okay, I need to delegate that to some driver component. And by doing so, you set up the driver and the connection pooling with a single URL without even touching your own code. And this is one of the cool things in RTDBC. Now, what do we get from RTDBC today? It is still a young venture. We are, however, on the road towards the 0.8 release. It's not a 1.0 release because throughout the course of RTDBC, we had made a lot of learnings, and we cannot entirely guarantee full binary backwards compatibility. We will get there eventually, but we are not there yet. However, we're good enough to go GA by end of this year, something like that. You get a couple of drivers, actually for Postgres, for MySQL, for SQL Server, that are all capable of doing batching, blob support, so for large objects. They have this extensive type conversion support that allows you to hand in various data types and make a sensible call out of that. They all support save points, transactions. They're leveraging database-specific features like translating back pressure into a cursor size, in a fetch size. We have this service loader-oriented loading mechanism where you just drop your driver onto the class path, and by providing a connection URL, RTDBC is able to figure out which driver has to be used. And what we have never also dreamed of is that we will get to the state where we have an ecosystem. Initially, this was just let's try to solve a particular problem. And we ended up with providing a common language for driver vendors to build drivers, and for client authors to code against a pluggable driver API. And this was perhaps not the initial idea. However, we are now there where we have a fully documented specification. We have various driver implementations that prove RTDBC is working. We have RTDBC SPI as an artifact itself. We have RTDBC Proxy. We have connection pooling. The community has picked up on various drivers, actually 2 drivers for MySQL. Google Cloud Spanner is writing its own driver for RTDBC. We have various client implementations with Spring Data, RTDBC, RTDBC Client. Juke is picking up on that, and there's a Kotlin driver, and I cannot really pronounce that name, so I won't even try. Now, you might ask yourself, what is this RTDBC proxy? Well, this is the first and biggest community contribution, and this solves the problem of observability. See, if you run your application with JDBC, you're probably interested in how many queries am I running, how long do they take, and these kind of things. And these are features that are given to you by frameworks like Datadog, Instana, Dynatrace, these kind of things. And since JDBC metrics isn't the most fun to do, because there is no standard for JDBC itself, these vendors need to augment your bytecode or hook into some driver-specific API. So we were asked by these folks, how do you see that? How can you provide something for APM vendors for metrics tracing? And somebody from San Francisco started a project on its own, which was called RTDBC Proxy, and this does exactly that. It wraps a connection factory, and then you can register callback hooks that are called once you issue your statement, once the statement completes. It gives you the timing information, how many rows came back, how long it took to give you all these information. And then you can take this information and put it into your Micrometer, into your Prometheus. If you are an APM vendor, you can build your APM solution on that. If you want to ship these metrics information to Zipkin or some other open tracing thing, then you are free to do so, because this gives you the ultimate insight what happens in your system when you are using RTDBC. Well, hearing all that might sound like magic, but really what RTDBC gives you is just solving a very particular problem. And this is solving the thread congestion in your JVM that arises out of blocking database access. Not more, not less. We have still to stick to the database-specific rules and the protocol rules that are imposed by the database vendors. They do not suddenly change things because a small fraction of users is going to do a fancy thing called reactive programming. We still have to talk with the same protocols. We have to obey the laws. If locking happens, yeah, these things happen, but they do not happen any longer within the JVM. They entirely happen on database level. This might lead to the fact that you probably need more connections than previously. But from a JVM perspective, that's a very convenient way how to look on that. From a database perspective, that's, however, a different topic. There are a couple of alternatives, like putting JDBC on a thread pool, because if you put something on a thread pool, then it looks like as if it would be non-blocking. Yeah, that works in sort of a test environment. But if we think about production environments where we talk about thousands, 10,000s, 100,000s of concurrent requests, this starts making no sense anymore. And the reason for that is, if I spin up a thread pool with like 10 threads, these threads are going to be exhausted and blocked pretty quickly if my queries have a significant query runtime. So this means my thread pool is pretty busy after a while. But what do I do with the request number 11, 12, and so on and so on? Well, either reject them, which is not cool, or the alternative is putting it into a queue. And in Java, there are 2 types of queues, blocking bounded ones and unbounded ones. If we use the unbounded ones, we effectively fill up all our memory with runnables. So at some point, we run into the out-of-memory exception. This isn't cool. So we probably shouldn't use the blocking bounded one. And if we cap that at, say, 500, then we get to request 499, 500, everything's cool. And then we suddenly get into request 501. Well, you know what a blocking queue does? It starts blocking. So we are basically where we started. There's also another category of alternatives, which are quite young specifications like ADBA. Vertex isn't really a driver with their Reactive First driver, but they start emerging into that direction with providing even more databases that they support. So this is another alternative. Or some drivers which are built entirely by the community. And the issue is, if I go on a community-based project, then I have to deal with different APIs. So this is probably not a good idea to provide a common layer of clients on top of that. With ADBA, this is driven by Oracle. Up to now, we have only a little bit of source code. Well, it is actually a fair chunk of source code, but we have no release yet. And you do not copy Oracle code if you do not want to get into legal trouble with Oracle. And the only running alternative or the only running implementation of ADBA is ADBA over JDBC, which brings us to the first bullet point, so probably not a thing. In any case, we will need to consolidate that ecosystem at some point and start collaborating and seeing which variant will be that one that is going to be adopted by the community, or how the community is going to be fragmented by this adoption. And since this is still a very young endeavor, we have to work in that direction. And RTDBC is the variant currently that has the most adoption amongst drivers and users across various drivers. So we will see how this goes. Now, Safe Harbor says everything that I said to you before is already available. Things that follow now might or might not happen, which is we have learned throughout the course that there are still folks using stored procedures. We initially thought nobody is using stored procedures. And then we learned, yeah, there are still a lot of folks that are using stored procedures, so we probably should support that. We also should support things like auto-commit mode, fetch size to give users more control over batch sizes, how data is obtained. And we also need another set of drivers. See, we have already SQL Server, MySQL, H2 for in-memory testing, Postgres, and Google Cloud Spanner. But we probably need more to have a very wide portfolio of supported databases. So DB2 folks are already investigating, SAP HANA folks are investigating. And ideally, we are able to move our drivers to the database vendors, since really we wanted to solve a specific problem. We are not the born driver developers. We want to see our families back, do other open source projects. So this is the idea behind of that. And what we also will see in the future is a rise in adoption amongst clients. So JDBI and MyBartis folks have already GitHub tickets open, and they are quite interested into that. We've been talking with folks from eBean who are also keen to provide these features. And we will see how this really turns out. And this brings us close to the end. So if you're interested in trying out RTDBC, if you want to contribute, if you want to give us feedback, do so. We have a website, RTDBC.io. We are available on Twitter, so at RTDBC. All that code is open source, Apache version 2 license. So it's a very permissive license, and you can even copy that into your own project without the need to contribute back. However, I would ask you to contribute back bug fixes. Not necessarily bugs, we are already taking care of contributing bugs to that, and other folks are fixing that. In any case, we have also a mailing list where we can exchange feedback, and feedback is really crucial for us, because still, this is a very young initiative, although we are already working on that since 2 years. If you feel that there are features missing, let us know. Only if we know about that, we can make that happen. If we don't know about that, we can't make it happen. Try this out in your projects. Try this out in your spikes. When it's going into production, try it also out on non-critical systems. I wouldn't really bet my life on RTDBC yet, but we are slowly getting there. And that being said, thanks a lot.